The first set of axes below shows the graph of y equals f of x for x between negative 4 and 4. And so on the first axis we have the graph of f of x. It looks like this and is defined for between negative 4 and 4. Let g of x equal the integral from negative 4 to x of f of t dt for x between negative 4 and 4. A. State the value of x at which g of x is a minimum. Okay. So what they're asking for is where g of x reaches a minimum. So what we need to realize is that we can actually do this without doing any sort of integration. We don't even need the equation for f here. So it's important to recognize that the integral is basically the area under a curve, or more specifically, it's the area between the curve and the x-axis. And if the area is underneath the x-axis, like in this case, it's going to be negative, and if it's above the x-axis, it's going to be positive. Okay, and so this g of x is simply the area from negative 4 to x, whatever you put in for x, of this function f of x here. So let's say if I was to put in x equals negative 4, that would mean that the area is 0 because we're at negative 4. If, let's say, I was to put in a more interesting number like negative 3 for x, then you would see that it would be from negative 4 to negative 3, and so it'd be negative 1. G of x would equal to negative 1. This is at this point, so I should say actually g of negative 3 would equal negative 1, okay? And what you should notice is that if I keep moving, so if I say g of negative 2, it'll be g of negative 2 will equal negative 2 because the area here will be 2 units squared, and we're under the x-axis, so it's negative. And if we go to negative 1, it should be negative 3. And what we should notice is that as we keep going, as long as we're under the x-axis, we're subtracting from the area, right? So we start at 0 and we keep subtracting. But when we reach the x-intercept of f at x equals 1, so this is x equals 1 at this point here, then now f of x is above the x-axis, and so what that means is that now we're going to be adding to g of x. So and we keep on adding as we go further along the x-axis, and so what that means is that we start at 0, we keep subtracting until we reach x equals 1, and then we start adding. So it should be obvious that the minimum we reach for g of x is at x equals 1. And so we can state that like so. Okay. B. On the second set of axes, sketch the graph of y equals g of x. Okay, so we know what g of x represents. We can actually do this by, yeah, we can just plot points in this case. Okay, so we're going to do B here. And as we discussed earlier, if we plug in negative 4, we should get 0. If we plug in negative 3, we should get negative 1. If we go to negative 2, which is somewhere here, we should get negative 2. If we go to negative 1, we should get negative 3, right? If we go to 0, we should be at negative 4, okay? And then if we go to 1, this is 4, everything up till 0. And then we're subtracting, rather, because it's under the x-axis, we're subtracting a half a unit squared. And so it should be negative 4.5. Okay, and now we're going to move, so now we're going to start adding since we're above the x-axis. So we add first a half. So this is a half. It might be a bit hard to see, but trust me, that's a half. So we go back to 4. And then we have 1.5. So negative 4 plus 1.5, that's negative 2.5. And then here we have 2 and 0.5, so 2.5 plus 2.5, so that should be 0. Okay, and then we can just connect the dots, but before we do that, we need to know the shape of this graph, of this curve, rather. So we should know is that, you should notice is that from negative 4 to 0, f of x is a straight line or a horizontal line, and the integral of that is a linear line because we move up in powers, and then from 0 to 4, f of x is a straight line, or sorry, not a straight line, a linear line like this. So it goes like that. And so the integral of that, so that's a polynomial to the power 1. And so the integral of that is going to be a polynomial to the power 2, or rather a quadratic. And so the shape of that should be a parabola. The integral should be a parabola. And so now we know the shape from -4 to 0 should be a straight line, like so. And then after that, it should be a parabola. So we can draw that as a curve like that. There we go.